Let's now solve one more exponential equation. We have 5 to the x minus 2 power equals 3 to the 3x plus 2 power. What we should notice first is that the bases are not equal to each other, nor can they be written so that they are equal to each other. Therefore, I cannot simply set the exponents equal to each other. So, we need to get the variable expressions out of the exponent. I can do that by taking the natural log of both sides of the equation. So I have the natural log of 5 to the x minus 2 power equals the natural log of 3 to the 3x plus 2 power. Because I'm taking the natural log, I can make this exponent a coefficient, and I get x minus 2 times the natural log of 5 equals 3x plus 2 times the natural log of 3. What I've just accomplished is created a linear equation in the variable x. It doesn't look like it, but it's the case. To make it look that way, let's go ahead and distribute, and I'm going to write this as the natural log of 5 times x. So the natural log of 5 is just a coefficient on x, minus 2 natural log 5. And on the right-hand side, I'm going to have 3 natural log 3 as a coefficient on x, plus 2 natural log 3. Perhaps now it does look like a linear equation in the variable x. With linear equations in the variable x, recall our method of solving is to get all the variables on one side, all the constants on the other. In order to do that, I'm going to subtract 3 natural log of 3x from both sides of the equation. So minus 3 natural log 3 and then x. And I'm going to add 2 natural log 5 to both sides of the equation. 2 natural log 5. So what I get on the left-hand side is going to be the natural log of 5 times x minus 3 natural log 3 times x. On the right-hand side, I'm going to have 2 natural log 3 plus 2 natural log 5. Now, on the left-hand side, do you see the common factor x? I factor that out, and I'm left in parentheses with natural log 5 minus 3 natural log 3. On the right-hand side, I have a common factor of 2. I'm just going to go ahead and pull that out, and I get natural log 3 plus natural log 5 left in the parentheses. Finally, if I divide both sides of the equation by natural log 5 minus 3 natural log 3, I'll have my answer. The answer is x equals 2 times the natural log of 3 plus the natural log of 5, divided by the natural log of 5 minus 3 natural log 3. Now this answer is exact. If I wanted an approximate answer, I would have to enter this expression into my calculator. I would get that x is approximately negative 3.212.
We just solved an exponential equation to obtain an exact solution. The problem was fairly involved, but we were still able to get that exact solution. In some cases, all we really need is an approximate solution. In those cases, we can use our graphing utility to speed up the process. We have two ways we can solve equations on our calculator. We can use the zero feature or the intersect feature. We want to solve the equation 5 to the x minus 2 equals 3 to the 3x plus 2. Since we have an expression on both sides of our equation, neither of which is 0, we're going to use the intersect option. We're going to do that by letting the left side equal y1 and the right side equal y2. We'll go to our graphing calculator and enter these expressions in y1 and y2. We'll press our y equal to button to pull up our y equal to menu. In y1, we're going to enter 5 raised to the x minus 2 power. Now we want x minus 2 to be the entire power, so we use parentheses to group the x minus 2 together. So here we have 5 raised to the x minus 2 power. Hit enter. In y2, we're going to enter the right side of our equation, which was 3 raised to the 3x plus 2 power. Again, we're going to use parentheses to group that power together. We'll have 3x plus 2. We're going to graph this on our standard viewing window by pressing zoom 6. Recall using the intersect method requires us to find the intersection points of the two graphs. When we graph this using our standard viewing window, we don't see any intersection points. Now we can use some trial and error. We can use the algebraic approach so we have some idea of what the solution will be to help us adjust our window settings. In this particular case, we're going to adjust our settings so that x min will be -4, x max will be 0, do an x scale of 1. Now here our y min will be -0.0005, and our y max will be 0.0015. And we'll scale by 0.0005. We graph that. Here we have the graph of y1, and we'll see the graph of y2 come through, and we do get an intersection point. So we'll go ahead and find that using our calc menu. The second and the trace key. Pick option number 5 for intersect. First curve is y1, press enter. Second curve is y2, press enter again. And for our guess, you're scaling by 1 along the x-axis. It looks like it's just past -3, so we'll use -3.1 for our guess. We find our intersection point is approximately -3.21, 2.28 times 10 to the -4th. So we'll go ahead and drag this over. When we're solving equations using our intersect feature, it's the x-coordinate of the intersection point that is the solution to the equation. In this particular case, the solution to our equation will be x approximately -3.21.